Yeah, welcome to the 2025 virtual town hall for OpenImageIO. Thanks to everybody who joined and to everybody watching later.
You want to introduce yourself too, just in case there are people here who don't know you?
Oh, yeah, of course. Yeah, my name is Danny Greenstein. I am a software engineer at Sony ImageWorks. I work closely with Larry. I deal a lot with textures and materials, so I use OpenImageIO pretty much on a daily basis, I would say, in one way or another. So, yeah, so for today, this is our agenda. We did a few announcements and some housekeeping. We're gonna look at just an intro of what OpenImageIO is for those who are not familiar with it. And we'll talk a little bit about what transpired over the last year. Then Larry's gonna give a really cool map of OpenImageIO, get into the architecture of the project, and provide some really interesting API examples, which is really, if you are new to the project, it is really interesting, or if you've used just the Python API, it'll introduce you to some of the C++ calls. So yeah, it's gonna be really interesting. And then our upcoming release is 3.1. So Larry will discuss some of the highlights from that release, specifically having to do with our safer API call. So that is also really interesting for people who are actively using the project, because we encourage you to move. The older calls are still going to be valid for a while, but the new ones are kind of the new recommended way of doing things. So yeah, let's get started, and then we'll cover some parting thoughts and just discuss how people can get involved and finish things up. And we'll have some time for Q&A if anybody has anything to share. So we'll just start a little bit with what is OpenImageIO. It is a tool set for reading, writing, and manipulating image files. It's image format agnostic. It's all the different images that are relevant for VFX animation. There's a rich API, it's scalable, it's robust, it has everything that you need for image manipulation for feature film production. A little bit of history. It started in 2008 as an open source project developed by Larry. It is one of the oldest VFX-specific open source libraries with over 230 contributors. It is used extensively in animation and VFX studios and in other industries as well. It's embedded in a lot of VCCs like Maya, Houdini, Katana, Blender, and many others. It's used inside most large DCC apps, renderers, and others. And it has been accepted to the Academy Software Foundation in 2023. We have a very active technical steering committee with members from a lot of other studios, large studios, and different. So we have representatives from Blender or from Autodesk. It's not just studios, it's also software companies. We meet once every 2 weeks, and a shout out to all the TSC members, and thank you to your contribution. Looking back at the past year, we've had a very active year, almost 400 commits by 41 unique contributors. This is the year. So the way the Academy Software Foundation works is projects start in incubation and then they graduate after they meet a certain criteria. So this year, OpenImageIO graduated from the incubation stage to an adopted stage. We've had our big 3.0 release last November. There have been constant, every first of the month patches. And one of the big things we've had this year is Python wheels for Python users. So you can download them and use the Python API, same way that you do every other Python package, in the way that all of us Python programmers are used to. We've had our dev days. There have been 2 dev days, so there's been a pretty good representation there with 13 merged PRs in the fall dev days, and then 5, a little less in the more recent ones that just happened a couple of months ago. And security-wise, we've made good progress in the OpenSSF criteria. We're passing 100%, 95% on the silver tier, up from 87, and we're 78% on the gold tier. So made good progress there as well. This was our big release in the last fall, and Larry's going to talk about the 3.1 release that's upcoming. But since last fall, we've had the 3.0 release out there. Some of the highlights are the removal of long deprecated APIs. Many dependencies have been bumped. Tighter integration with OpenColor.io, which leads to more consistent color management, which is something that we are all relying on every day. The build system has been overhauled. We have the auto building. It's a project with a lot of dependencies, so the auto building works better. We got rid of Boost, which has been a long-standing wish of ours. There is support for, Larry will go over later about the architecture of OpenImageIO, but part of the beauty is that it's format agnostic, so we can add more formats, but the API calls pretty much stay the same regardless of the file that you pass. So there's support for new formats. There is new algorithms for demosaicing raw images. We'll talk later about OpenImageIO tool, which is kind of the Swiss Army knife of image manipulation. All of us, I use it pretty much every day, and there's always new options and new features, including some of the ones that we have here. And this is just a short list. There's been hundreds more of fixes and enhancements from a variety of contributors. This is just kind of an overview of the different contributors since around last year. So you can see that I think we said 41. So that should be it here. Some of them are longtime contributors. Some of them are here in this meeting. Some of them are new. Some joined for the dev days. As I'm looking at this, I kind of thought it would be cool one day to do it on a globe or something, because some of these contributors are from really interesting places in the world also.
That's a great idea, Danny. We never thought of that, but it would be pretty cool to put pins on the map or something. But if I can jump in here for just a second, like this slide is something that we're really proud of. You know, sometimes we complain about things, or we beg for more participation or something, but I think this really speaks to, in the grand scheme of things, the health of the project. Having this many unique contributors in a year and this many new contributors to the project is something that like we're especially proud of that, and I think it's a great sign that that we're relevant and attracting people who can make contributions.
Yeah, it's sometimes surprising to see where the contributions come from. So there are a few there that surprised me, and it just, it shows the reach of things. And but I think I'm going to pass it on to Larry from here to talk about the architecture of the project. And this is a really cool part of the presentation. So if you're watching on YouTube.
Yeah, there's a message in the chat from Joseph. Is everyone seeing the slides that we've been showing? Okay, so it's just Joseph. Huh. Okay.
Okay, so I'm going to stop the share, and this is a good opportunity to refresh the slides. So maybe that will solve Joseph's issue.
Yeah, let me see. Let me see if I can share from my end. Danny, did you do the slideshow on the browser first and then switch to Zoom, or how did you?
I usually share the
the
browser first, just because it's easier to find it on the list of windows that it shows you, and then there we go.
Or do you see the slide now again?
Yeah, I can see them now.
Okay, Cool. All right. So yeah, so this is going to be a little bit introductory, but I hope that everybody has something that they can get out of it. It's all, I actually found going over this that it was helpful even for me to kind of put the different pieces in perspective. So I want to give a little bit of an overview of kind of the different components of the package and how they fit together, mostly through the lens of sort of the different APIs and levels of abstraction that we have. So at the core of things, at the low level, are classes called image input and image output. And these are, as Danny said, like the sort of the basis for the specific, file format agnostic nature of everything that we're doing. And these are responsible for, what I would describe as the sort of file level abstraction of the images. So, the kinds of operations that they're dealing with conceptually are like opening and closing files, finding out about the shape and metadata of the image that's in the file, reading individual scan lines or tiles or a whole image, into memory that you provide the caller provides a buffer for. And so like, that's the sort of level of detail that you're dealing with and the sort of conceptual, outlook of it. So as I go through each of these, I'll give real, sort of brief, sketches of like what the APIs look like, but don't feel like you need to get every line. And so living under those are subclasses that implement the individual file types, like things like OpenEXR or TIFF or JPEG or so on. I didn't list them all here. We've got, maybe a couple dozen in total. Vast amounts if you count that a couple of the implementations themselves handled many, like, we count, camera raw images as one plugin. But actually it's libraw underneath. So there's, dozens of camera raw formats that it knows how to read. And similarly for the one that can read video files, which is based on FFmpeg, there are many, many, many video types that it's capable of reading. So it's hard to get a sort of accurate census of it all, but we think of some of those as being individual ones. So underneath those are separate implementations, but from the point of view of an application, they're all just going through the image input and image output APIs, and you don't need to know the details of any of the particular file formats. That's all just handled for you. So living on top of that, then there are a couple of components that are around this image buff class. So this is a different level of abstraction. Here with image buff, we are not dealing with files. I mean, you may name a file, but it's really, you're treating it as a name, but you're not worried about opening or closing. There's no concepts of scan lines or tiles at this point. Things are lazily read as you are doing operations that need to know the metadata or the pixel values, and all of that, the file-based stuff is happening underneath independently. For the most part, the image buff owns the memory of any pixels that are stored, although just as a footnote, it's possible to make image buffs that are sort of wrap application buffers, so you can own the memory too if you want to, or also that are backed by the image cache, which we'll get to shortly. But like, think of it primarily as the image buff object owns the memory of the pixels, and you can treat it for the most part as if everything is floating point value inside there, and that may or may not be true underneath, and you can behave as if it is. And there's a few different ways to access the individual pixels. There are calls to individually get and set them. Those tend to be very slow. There are slightly more complicated methods for iterating over them, and which handles all the data translation for you. And that's how the image buff algo functions are implemented, in fact. So then there is a collection of these utility functions called image buff algo, and these are all of the sort of whole image oriented image processing functionality. I'll talk about them as if they always operate on the whole image, but it is technically possible to tell them to operate on individual rectangular windows within them if you want. And so this is just like a long laundry list of different kinds of image operations that you would do, whether it's things like shuffling channels around, or cropping the size, or resizing the image, doing image arithmetic on one or more images, comparing images or getting statistics about them, and all sorts of other things. And prominent in there also are color management, doing things like color transformations. And underneath that is all powered by OpenColorIO. But we wrap those things so that even though you're using OpenColorIO underneath, the app level can do it all through OpenImageIO and not need to separately, deal with OpenColorIO's APIs or linkage or data types or any of that. And so, what this kind of looks like is, you are just, instantiating an image buff, maybe telling it a name of, where that is stored in a file, but then that's it. There's no other color things. So you can just directly take those and do things like compositing operations or other image manipulation. And it will handle all of the reading, writing underneath and pixel traversal, all that stuff. So like mostly, unless you have to do things that are particular to individual pixels, you're just dealing with the abstraction of a whole image and telling it what to do to it. Add this image to another one, or resize it to this resolution, write it up to disk, that sort of thing. We should note that most of the examples that I've been giving are C++, but actually, all of these interfaces have Python bindings as well. So particularly in production studios, there's Python scripting is big. So we've tried as hard as we can to make a one-to-one correspondence between the C++ APIs and the Python APIs, so that anyone familiar with one, it's a very small step to know what to do with the other. But there are some small differences, and when something that we would do in C++ is very un-Pythonic, we try to have a more idiomatic way to do it. But where they don't have to diverge, we try to keep them similar wherever possible. So just in this short example, you can see, a very close to one-to-one mapping between these things. So on top of these classes are also some command line utilities. And right now, the only one I'm going to talk about is OpenImageIO tool. The others sometimes are sort of specialized things, but none of them can do things that, like OpenImageIO tool is like the superset of all of them. So I'll just talk about that for now. So this is a command line utility that essentially wraps all of the functionality of ImageBuff and ImageBuff-IO and a little bit more. So the way to think about how you use it on the command line is it's a sequence of arguments on the command line that are processed left to right, like in order. And so the two things that happen is anytime an argument is the name of an image, that is putting it on the stack. Everything else is pushed down, that becomes the new top. And various commands operate on the top image, or sometimes the top two or more images. And so think of those as like it removes one or two images, does some computation, and then puts the result back on and makes that the new top. Unlike some programs that kind of look at all the arguments and set flags and then go process, this is actually kind of processing left to right as it goes and parses the arguments. So just a few kind of things that we do all day long, every day with this utility. We can use it to, just very simply translate an image from one file format to another, to do things like change the data representation, so from a 8-bit unsigned integers to 16-bit, and so on, to do color space transformations. things like shuffling or renaming channels in images. At the end here, I have the one example of reading in a movie file, extracting one particular frame from it and saving it out as an individual image. And lots and lots of image processing kind of utilities, resizing, rescaling the data values, doing things like image arithmetic with multiple images or simple compositing. We can sort of burn in arbitrary text onto the image, to add titles or whatever. And a few tricks, if you haven't stumbled on these on your own, this is part of what makes it really handy for scripting on the command line. One thing is that there are a few symbols that it knows to think of as like numeric wildcard expansion. So you can, if you have a lot of images that are numbered, as often happens in production, you have a directory full of frames, 1, 2, 3, 4, and so on. One command can do the same operation to all of the sequences of files, and it will know, for example, in the first example on the slide, it will substitute the same frame number for all of the number signs that get expanded, and it will do it by taking inventory of the files that match those patterns first, deriving from that all of the frame numbers that are involved in that set, and then going and executing the command with those frame numbers substituted sort of one at a time. The other thing to know is that anything enclosed in curly braces will have expression evaluation done on it before the commands are run. So there are ways to do some simple arithmetic to extract metadata from the files and so on. So like in this middle example, it wants to put text onto the image, and the text so it first loads this file in.exr. That becomes what we call the top of the stack. So the text it's going to write is the image description metadata field that was in that file, and where it's going to put it on is actually it can compute based on the resolution of the image to make sure that it's sort of close to the bottom. But it doesn't, when you type this command in, you don't have to know what the resolution is. It's always going to put it 40 pixels from the bottom and 10 pixels from the left. It is also possible to write loops and conditionals on the command line so that certain commands, either are repeated or only happen conditionally based on other things that you can test with these expressions. So I have a really perverse example. If you really wanted to go nuts, you can have nested loops and all sorts of computations. And I don't know if anyone would recognize the math here, but maybe you do. But this actually computes this image just like straight from the command line. It's not the fast way to do it, but sometimes you just need the big hammer to do something flexibly. Another sort of different abstraction level that we have is the image cache and texture system. So the abstraction here is when you're dealing with a potentially, vast number of images and, immense total number of pixels, and that much more that can fit in memory. And you don't want to have to think about files or memory management or any of those limits. And so the basic, operations are just like, give me this set of pixels from this file, or I want a filtered texture lookup at these coordinates, with this set of derivatives. And you don't want to have to worry anything about where those pixels came from and how the resources are managed. So no opening and closing files, no keeping track of the number of open file handles, how much memory anything takes. And it works super well, but particularly if the set of files that you're dealing with are tile oriented and not completely incoherent. Like if you literally are picking like one random pixel you know, from a huge set and you're bouncing around, that's not a great access pattern. But in the kinds of access patterns that you would usually see in a renderer, access and texture, this is really good. And so just as an example, you know, many renderers use this as their texture system, and it's completely normal, you know, everyday business to have a scene where each frame references, you know, 2 or more terabytes of total texture spread across, you know, a couple tens of thousands or more individual texture files. And we can do all of that with an in-memory footprint of, you know, under 10 gigabytes and, you know, very little repeated reading of things multiple times. So very efficient. And then, so then, like I said, on top of that, sit a lot of renderers that use both the texture system as their texture system, but and also usually the other parts of OpenImageIO for just, you know, the ordinary things like a renderer's got to output images to disk in particular formats, and just you can sort of outsource all of this. So that's the tour overall. I think those are all of the major system components and how they fit together. And so I think that, you know, the sort of parting thought on that is, you know, often, you know, people ask, like, how do I do this thing with OpenImageIO? And there's usually not a single straightforward way. Usually the first, you know, follow-up, you know, question is going to be, like, what's the appropriate level of abstraction that you want to deal with? And then that can direct you to sort of which of these different, you know, classes to think of as your primary interface for how you want to do that task. Any questions about any of that before I move on to the next topic? Great. Let's talk about the release. So it is the time of year where we do the big releases. I think Danny said we aim very hard to have a patch release at the first of every month, or as close to that as we can get. And we do roll new features into those as long as we can do it safely. And so the two constraints that we have is that on the patch releases, we will never change the minimum versions of any of our dependencies. We will not break API or ABI in a back compatible way, meaning that you should be able to, if you have an application that was made for one version, you should be able to upgrade to the next patch and just relink it and not even need to recompile. And so we don't break back compatibility in that way, or introduce changes that are going to change default behaviors or do anything that seems risky to put into a production release. And then once a year, we have a big release where we are allowed to break some of those things. So we may change minimum dependencies. We may introduce features in a non-back compatible way, or change behaviors, or do other things that you know, could change workflows possibly. So the OpenImageIO is not a VFX reference platform named package, but because this causes a bunch of other things in our ecosystems to get updated in this time of the fall, we try to go along with that to have similar timing so that we're not terribly out of sync. So the schedule we're aiming for this fall is shockingly close to now. We're aiming for August 15th, which is right at the end of SIGGRAPH, to branch for 3.1 and declare a beta to have people begin to test it seriously. We will try at that point to no longer break back compatibility. By September 1st, we hope to have a first release candidate, at which point we will introduce no changes that aren't build fixes or really critical bug fixes. We want to really try to lock it down for stability between then and the release, which we are aiming for on September 15th. These dates are all, you know, tentative. We may miss it by a few days or more if something comes up that really needs a more extensive fix. but that's the penciled in set of dates that we're worried about. Now, after that happens on September 15th, so that would make 3.1 the fully supported release family that from that point on we'll get monthly updates with whatever fixes we come up with, and including new features that can be safely backported. The 3.0, which today is the supported release, will become the legacy branch. We will keep making patches there for important things, mostly bug fixes or sometimes other things upon request, but over time, over the course of the next year, that will, those updates will become more and more infrequent and eventually tail off. And what's currently the legacy branch of 2.5, which barely gets any updates at all, will definitely not get anything after September, unless there's some amazing emergency. And at that point, the main branch, what we call main, that will be the in progress work on what will be a 3.2 release a year from now. And so in main, things are able to break at any time. Now, I use break in a very particular way. This is a fairly mature project and we're very careful with it. And rarely do we introduce like bad bugs in main. And many people work, in production fairly close to the tip of main. I don't mean to imply that it isn't production worthy pretty much at all times. But by breaking, I mean, we could do things that change behavior, we hope for the better, or change the APIs in a way that's not strictly compatible. That's allowed to happen in main. So if you want to work out of main, just like be aware of that. But that said, like we do believe in the software and it should do its job just fine. We can't guarantee that tomorrow we won't check in a change that, slightly breaks compatibility for you if you were right there in the tip. But within the release branches, the APIs are totally stable. So a few things that are coming, meaning work that we've done over the course of the last year, but that hasn't made it into the 3.0 release branches, but then will be introduced with 3.1. So I think we are continuing to push forward with more ability for the auto builds, and just to expand on that, this OpenImageIO has a lot of dependencies, mostly because we support a lot of different file formats underneath, and this can make OpenImageIO tricky to build. Less so because of it in particular, but more because you've got to build all the dependencies first, and then OpenImageIO has to know how to deal with whichever versions you have. Like we often don't dictate a specific version of each dependency, but really we try to cater to a range because we want to be able to fit into a variety of pipelines where different GCCs or different studios may have slightly different sets of dependencies that they need to work. So the auto build is a way for us for the build system to automatically see that for some dependency at once, there's no version it can find, in the range of versions that it wants to deal with. And so it has the ability to automatically download and build it from source and just compile it into our library, hopefully unaided. And so we don't do that for all the dependencies, but we try to do it for the most important ones, and we're trying to slowly expand that list. We have two new file formats. One is Ultra HDR, which is technically not a new file format in the sense that it is in current JPEG files, and they can even be read as ordinary JPEGs by applications that don't know about the Ultra HDR. But the trick that it uses is that there's a data area where it has the extra information it needs for the HDR information. And so the slick thing about this is if you have a viewer or some other application that knows how to read regular old JPEGs, you'll get the SDR version. It will appear to read it as non-HDR and look fine. But if you have any Ultra HDR aware reader, you have the extra extra information. And we also added ability for HTJ2K. And in particular, a lossless version of that is being added to OpenEXR as well. So if you're building against the latest, about to be new OpenEXR version, you'll also be able to use that compression method within your OpenEXR files. A big theme of this year's release is trying to move to safer C++ APIs. I'll go into a little bit more detail of that in a minute. And another big change that we have coming is to continued improvements to the color workflow. And in particular here, there's a group under OpenColorIO called the Color Interchange Interop Forum. Yeah, sorry if I mangled that, CIF folks. But like the idea is like across all of these libraries and applications that deal with color information and OCIO configs, there has been a sort of lack of standardization of which color spaces you can find in a config and the particular names used for them. And that creates a lot of confusion. And so there is an effort to try to come up with a standard set of names for the commonly used color spaces. So all of these apps can be using the same language. And, you know, if we save a file and put in the metadata, oh, these pixels are, you know, ACCG, you know, we can use a token that everyone else has agreed to mean that color space. And so we can read and write, you know, across a bunch of different apps and libraries and have a common language about that. So we're trying to standardize as much as possible within OpenImageIO on those conventions being set up. So hopefully that will give just a more uniform approach to the color management terminology. So yeah, let's talk a couple minutes about what I mean by safer C++ APIs. So yeah, sorry, this part's going to be very C++ inside baseball. So if you're not a C++ programmer, you can nod off for a minute. It's okay, but I think this is interesting. So a typical sort of old school C or C++ way of making a call to a function, and we have this all through our APIs, is a function that takes you know, a pointer to an array of values, like pixel values, say, and then it, you know, within that function, it's going to, you know, access it, you know, and this is really error prone, and you know, like the most important thing is that there's an assumption here that the length of that array is, you know, what the callee assumes it is, and that the caller pointed it to a chunk of memory that is big enough and has all the values set correctly. But neither side really guarantees that. Like the caller, it just sees this call to myfunc, and it's like it's crossing its fingers and hoping that the you know, the implementation is not going past the bounds of the buffer it gave it. And the implementation similarly is crossing its fingers and hoping that the caller, you know, gave it a big enough, you know, buffer for the thing that it wants to do. And neither of these is checked in any meaningful way. So it's just a recipe for subtle bugs, even though we try to be careful. So we can get a little bit closer by, instead of passing just the pointer, we can pass both the pointer and size. And so that can lead to a little bit more agreement between the caller and the callee, but there's still a lot taken on faith, beginning with the fact that you're hoping that both sides, you know, you see a function with a signature like this, and you're hoping that it's a promise that's honored by both sides to give a chunk big enough for the end you're passing, and to not access, you know, beyond that on the other side. And so you can be meticulously careful and make sure those promises are met, but it's all on the honor system. So maybe it works. So C++ 20 introduced something called std span. We have our own version of it that we use partly because we don't require C++20 yet. We're still C++17 minimum. So we wanted to bring that to you sooner, but also to sort of insulate us from any, compiler specific, implementation oddities. But the idea of a span is a non-owning reference to a contiguous series of objects with known length. So think of it as like a reference to an array, but it's non-owning. And we also, there's something we call the C-span, which is just shorthand for a span of constant objects that are not able to be modified, right? Like read-only, right? So I'll go back a slide. So the new way of writing these problematic loops would be more like you pass the function argument is a span, and that encompasses both the pointer and the length for it. And so, you can have the implementation then with that one parameter, like understand what the safe parts of the memory can be. And in debug mode, we even do that with full range checking at some performance costs, but that really helps us, sort of ferret out the subtle, buffer length errors that we can get. And then we also expand this since we're dealing with images all the time, which are, images are X and Y resolution, and in our case, sometimes Z if it's volumetric, and number of channels. So we've got this multi-dimensional thing, and each dimension might have its own length and also strides, right? Meaning like it doesn't have to be contiguous. So like imagine that you have a full image that is contiguous, but you want to talk about, a rectangle in the middle of it. And so like if you think about the memory layout, it may still be contiguous, like, in the X dimension, but when you step from one scan line to another, you have to, you have a non-contiguous stride, if you know what I mean, right? And so there's a way to specify that. And so these things are fully range checked in all dimensions in debug mode. And so now we can pass a single parameter that it sort of sweeps up what used to be a bunch of different parameters of the pointer, the bounds in each dimension, and the strides for each dimension. And so it's actually really convenient. Also, and it's done as a template, so it can be multiple types. And if the type is standard byte, that is our notation for it's untyped memory. You're just giving the memory layout and the striding, but maybe the data type is understood or doesn't matter if it's just copying it around or something. And so an example of that is we used to have an old API, for writing an image that would take a thing we call a type desk that says what is the underlying data type of the buffer, a void pointer for the beginning of the buffer, implied bounds by the resolution of the image that it thinks it's dealing with no real way to double check it, and then optional strides. And I should just say, this token auto stride is something we use all through our APIs to mean compute what it needs to be in order to imply contiguous striding. Like I don't need to think about it because there's no gaps. And so this old style raw pointer based API is being replaced by a triplet of related ones, a fully templated one that takes an image span, one that of arbitrary type, where that conveys the type as well. One that takes an explicit type and then a span of bytes. So you're sort of giving the memory layout as untyped memory and separately saying what the type is going to be. And people check that those things, seem to match appropriately. And then also one for the completely contiguous and typed case, where you just give it a regular old span. So where are we with these? So 3.1 has added these, we think, for all of the places that used to take these sort of dangerous raw pointer calls, so that in particular, anything that's getting or retrieving blocks of pixels that need to write them into buffers, things that are setting or getting metadata and needs to put that someplace. We think we caught all the places. There may be a few stray ones that we patch up later, but I think we got the main ones so far. And so there's sort of 4 varieties of those depending on the use case. Some things take a span of arbitrary type or a type desc and a span of bytes. Those are cases where we know the thing is going to be contiguous. And other things that are sort of more image-like and might need striding, take an image span of arbitrary type or an explicit type and an image span of bytes. So the older versions with the raw pointers still exist. So if you're stuck, you can use those, but we hope to eventually deprecate. I think this is where I switch it to Danny, but maybe I'll keep driving the slides and you just tell me when to switch because I took longer than I thought I would.
I mean, you can talk about this slide if you want.
Oh, okay, sure.
Small,
Sure.
medium look.
Yeah, so beyond that, some other things that are on our horizon, some of which have people lined up to do with them and some don't. So small tasks that come up with us continuously, and we're always looking for help from anyone who's willing to give it, are just the general issues of like support and issue triage, answering user questions, dealing with the constant barrage of, a dependency will come out with a new version of itself and it's slightly incompatible and we have to, match the APIs on our end, or something about the CI will break and we have to keep that working. And, always thinking hard about how to test the different combinations that people will try to use for building. Windows, for anyone out there who considers themselves a Windows expert, I am not, Danny is not. So a lot of us, and a lot of these ASWF projects generally have ongoing issues with needing more help from people with Windows experience. Slightly bigger things, like I said, we're in the middle of overhauling some of the color management and bringing it up to date with hot off the presses work from OpenColorIO and the Color Interop Forum. And I think we're overdue for some big overhauls in the way we handle camera raw, HEIC, and video files. And like more long-term big projects, I think we would love to see a kind of a more native CUDA and optics version of the texture system, something that provides a similar interface and feature parity with what we have now, but is callable from CUDA and optics-based renderers. And we've also been talking for a long time about wanting Rust bindings for everything, and that is a project that goes in fits and starts and doesn't have a lot of active work being done on it now, but that is not for lack of desire to see it happen eventually. So if there are any people out there who really want to work on Rust, there's a lot that can be done. All right, now I'll pass it back to Tim.
Oh, thank you. Yeah, let's move to the next slide. Yeah, so there's a lot that is obviously working. It's a heavily used project. It's an essential part of the VFX and the digital filmmaking process. It is very hard to find a studio or a pipeline in a studio that doesn't use it, or a DCC that doesn't use it. So it's pretty much in all of your favorite films or TV shows. We're constantly adding new features, improving things, bug fixes. The technical steering committee is working. We have good attendance at the meetings. And we have a lot of contributions. We've had a decent amount of contributions in the past year. So a lot of stuff is working and needs to be celebrated. Let's move to the next slide. We wouldn't use the term not working, but we'll leave you with some parting thoughts as far as I think a lot of people, including myself and including people in our company, kind of see the project as kind of a black box that always works. And a lot of people use it extensively. Like we have a lot of people that are OIIO tool ninjas, but they don't really get into the weeds of how things work. So the idea is that if some of the big studios that use the project extensively would find some people to dedicate a consistent amount of time, then all the good things that already work it will be a huge force multiplier to the improvement of the project. So that's something we're trying to do internally, and we encourage other large studios to do the same thing. And if you're interested, then we have the concept of a mackerel, which is kind of like came from the idea of teaching somebody how to fish versus giving them the fish. So there are certain issues that we tag as a mackerel, which are really good first issues. They're not super easy, so they're not super lightweight, but they're not super deep. They're kind of really good issues for, if you get through that one, you get a pretty decent understanding of the code base, or a good part of the code base. So if you're interested in joining or in contributing, this is a good tag to look for in our issues. Let's go to the next slide. And yeah, another good way of getting involved is the ASWF organized Dev Days, which is kind of a hackathon or FedEx Day. The next one is coming in the 25th of September. Yeah, so there is a registration link here. It's a great way to find a small task and kind of challenge yourself to finish it in a certain amount of time. We internally, we try to, if you're in a large studio, we try to organize it and encourage a lot of the people that use the code on a daily basis. They use the tools on a daily basis to participate, and it's been a really good experience for them. So it's a good way to learn how your favorite tools work, and the people behind, get to know the people behind them. Yeah, we encourage people to sign up a little bit early, because you need to get your CLA signed, and the company, sometimes it needs to be company-wide, and you need to pick an issue. So try to join a little, look into it a little bit early, right before the day, so that you have your preferred issue already picked, and all the bits of bureaucracy that are required to contribute and push all squared away. But yeah, it's a really good way of getting your feet wet in the water a little bit. Let's move to the next slide. And yeah, everything that we've talked about here is a lot of it is available on the GitHub page of the project. A lot of the information. So if you're interested in getting involved, that's a really great place to start to look for information. We have a fairly active Slack channel, which is also a good place where people ask for support, and we meet every 2 weeks. The TSC meets and other people join. So that's a good way of getting in touch with us. So if you want to get involved, there's plenty of ways to get involved and plenty of ways to reach us. Let's go to the next slide, which I think leaves us, sadly, a very short amount of time for the open discussion. I didn't see anything hit the Q&A, but there is, well, the Slack channel is always open if anybody had questions, or if anybody wants there was some really good examples and code snippets in the slides. So if you want a copy of the slides, then feel free to reach out. I think that's the end of the slides. Is there anything after that?
I don't think so. I think that was,
Yeah,
I think
that's that. Yeah. So I think we made it just with a minute to spare. But if
there are quick questions, I think we might be able to take one or two. If not, yeah, I think, yeah, you know how to reach us. We're active on the project Slack in the ASWF Slack instance for the OpenImageIO channel. And yeah, the Zoom meetings for the TSC are open. Just access the ASWF calendar and look for it, and it'll give you the Zoom link and let you sign up. And we won't have a BOF at SIGGRAPH, but we will be at the beer party and wandering the halls. So yeah, introduce yourself if you run into us there. Everybody have a good SIGGRAPH, safe travels, and we'll see you in Vancouver next week.